Hello, I'm Adam,
And I'm John.
and today we're doing a proposal about the paper Performance Analysis of a Proposed Solar HDH Water Desalination Systems for Hot and Humid Climate Cities for our ME4622 undergraduate seminar class on July 29th, 2021. The proposal presentation is broken down into three main categories: the literature survey, the improvement proposal, and the references.
The first paper, titled Humidification, Dehumidification, Desalinization Systems Driven by Thermal-Based Renewable and Low-Grade Energy Sources, a Critical Review. For the second paper, we found an experimental investigation of the energy and exergy performance of a direct evaporative cooler using a new pad type.
The third paper we looked at was the energetic, entropic, and economic analysis of an open air, open water humidification, dehumidification, desalination system with a packing bed dehumidifier. It evaluates and breaks down the economics behind creating water using the HDH system and logistics of it. The fourth paper was an augmented productivity of solar distillers integrated to an HDH unit, experimental implementation.
For the fifth study, we found an optimal operation conditions of a hybrid humidification, dehumidification, and heat pump desalinization system with multi-objective particle swarm algorithm. And that uses an algorithm to discover the optimal operation of the hybrid HDH system. For the sixth paper, we found an analytical numerical schemes for thermodynamically balanced humidification, dehumidification, desalinization system.
The seventh study we looked at was a graphical method for the determination of optimum operating parameters in a humidification, dehumidification, desalination system. This looks at the PHCR, or pinch point heat capacity ratio, for optimum energy consumption. The eighth study was performance analysis of a multi-staged humidification, dehumidification, desalination system with different salinity levels.
For the ninth study, it was a solar humidification, dehumidification, desalinization system, a critical review, which was a compilation of previous studies regarding solar humidification, dehumidification, desalinization systems. For the 10th paper, it was a review on recent advancements in humidification, dehumidification, desalinization systems with integrated and refrigerated power and desalinization technologies.
Overall, over the literature study, the conclusions we found were that the addition of a wooden cellulose pad results in a 34% increase in distillate than a normal circulation in HDH systems. Using a multi-objective particle swarm optimization algorithm could also provide accurate simulation of an HDH system. It highlights the linear relationship between the optimized cost and electricity price, which is only revealed through the algorithm. We also found that thermal balancing and graphical models were shown to be more accurate for representing and optimizing an HDH system, and that salinity levels showed a decrease in water productivity at a rate of 0.75% for every 1% of increased salinity, to be kept at below 50%.
As far as aspects that were not considered by the paper, the ability of the systems to operate at specified temperatures and humidities were not investigated. The idea of the system only existing in controlled conditions is unrealistic. And re-evaluating the results with real systems would provide more insight into the different systems' behavior. Incorporating evaporation pads in the stills made from cellulose would increase the system efficiency. And using advanced modeling algorithms like multi-objective particle swarm optimization, thermal balancing, and graphical modeling to optimize the HDH systems.
As for how to improve the original study, as the goal is to provide the most clean water at the lowest cost, there should be a measurement between the single stage system, the double stage system, and the modified double stage systems. Total water production is a function of the cost that is required to operate and create the systems. Increasing the mass flow rate increases water production, but the study doesn't pursue the optimal mass flow rate for each different type of system at different conditions. Otherwise, possible hybridization of the desalination system could increase efficiency for the overall system production. And these are our references.